Good day everyone, and welcome back to the X Explorer for another video. I'm Yankee Oscar 6 Delta X-Ray Echo, and today we're not going to build anything, but we are going to talk about all the projects that I presented on YouTube so far, most of them actually. And it comes to the PCB board designs, and we're going to talk about each design step by step and all the updates that I made for 2025, because I just finished updating all the PCB project files on PCBway, and I wanted to talk to you about each modification, why I made that modification, and so on. So very soon also I will start posting all the blog articles for each project. I already started preparing all the articles. I have two of them published right now, but I'm going to come with more. And we have a bunch of new PCB board designs coming soon together with a blog article. And yeah, I'm really excited. I just placed my order today with PCBway. I'm waiting for the PCB boards to arrive with updated designs, and then I can start constructing each of them, putting them together, and finally have all of them in enclosures. Because look at the Sputnik region receiver, it's the same 2 years later. I didn't have the time to put it in an enclosure, so I think it's about time. But of course, I'm not going to continue without saying thank you to my friends at PCBway for always sponsoring and supporting the DX Explorer channel. Remember, they have great PCB prototyping services, PCB assembly, SMD stencils, CNC, 3D printing, and a lot more available for you. Now you will have to take advantage of the Christmas sale that will start on November 28 and it will last until December 28. You will have to take advantage of the massive coupons that will be available site-wise. You get free specialty inks, purple, matte black and pink at no extra cost. You also have material discounts, and you can save 10% off on UTR 8100 Full Clear and Somos Lido. And yeah, I think it's great. You will have to take advantage of these Christmas sales. If you don't have an account for PCBway, have a look down in the video description. You'll find the link that you can use to register for your new account, and you'll get a discount on your first order. As I'm always saying, PCBway is the way. So let's talk really quick about each design and what changes I made and what's the reason behind it, just because I wanted you to be up to date with all the modifications until I get to write the blog article, and of course you'll find details over there. So for the Sputnik region receiver, the only thing that I did, and I did this actually on all the designs, you see these small pins over here, the space for the pins actually. Let me show you on the actual receiver. So I have these two pins, and they were separate, and you had to solder them separate. So what I decided to do is to minimize the space between the holes, so you will be able to solder two pins at once, so they will be stuck to each other. You don't have to break them anymore in separate individual pieces. So that's what I did to all the PCB board designs, and that's what I'm going to use from now on. And the only modification that I did over here, it was to change the trimmer resistor for a smaller version, and that's the only change that I made to the Sputnik radio receiver. I kept everything else as it was because I really liked the way it turned out. And I have 3 boards over here. Now let's talk really quick about the K8 T&D Spherix receiver. Same thing over here. For the bias trimmer resistor, I'm using a smaller version. I'm also using a smaller size potentiometer that it will make it easier for you to fit the whole thing into a smaller enclosure. And also you will have the audio output directly on the board. I don't have the new boards, I'm still waiting for mine, but I cannot wait to get the new updated boards, and I will also start finishing all my projects. What else? I think that's it about this one. When it comes to the audible RF field strength meter, which is the Squeaky, designed by VK3 Yankee Echo, or at least that's where I got the schematic from. In here I'm also using a smaller size potentiometer just for the same reason that you will be able to place the whole thing into a smaller enclosure. Let's talk about the PTTCO. I think this is, yeah, this is the PTTCO CW transceiver. So at some point I actually wanted to give up on these two trimmer capacitors, but I decided to keep them. What I did change, if you remember, I think in some of the latest videos I was using a 2N2222A TO18 metal can transistor. Unfortunately the power output wasn't so great with that one, so the reason because that I was using a metal can was that I'm able to put a heatsink on top and keep it cool a little bit, because the transistor over here is kind of heating up a little bit. So that's the reason why I changed to metal can. But because the power output wasn't so great, I returned back to the original design that Miguel had, using a TO92 style plastic transistor, basically just a regular 2N2222, and I'm using that one instead in the new design. The resistor R2 in our case over here. Now in the original schematic from Miguel, this is I believe 4.7 kilo ohms, and he also recommended that you can go as high as 10 kilo ohms. So in the official schematic, basically on the website, on the blog articles and on the PCBway project and in the boom file, I'm using a 10 kilo ohms resistor. And if you read the blog article on this one, you'll find the reason why I'm using 10 kilo ohms. But if you want, you can do something in between. Like for example, in my own version of PTTCO that I have back home, I replaced it with 6.8 kilo ohms, and that has to do, especially if you're watching the video, it has to do with a side tone, not the side tone level, the RF level of the oscillator. So if the value is lower over here, let's say you have 2.2 kilo ohms, if you listen into an SDR receiver somewhere close to you, chances are that you will actually hear the oscillator without even keying the transmitter side. So that's not a good thing, and Miguel increased that value to 4.7 kilo ohms, and it was fine for him. But for safety, I increased that to 10 kilo ohms, and I had good results with that. But of course, just because I decided that in my own version I will have something in between, I'm using 6.8 kilo ohms. Now these two capacitors, again, I'm using C3 to retune the crystal on 7.030 megahertz, and because I wanted to transmit exactly on 7.030, I added C3, which is actually changing the frequency a little bit, and it allows me to tune it on 7.0 megahertz. And C4, it will be used for the frequency offset. And as soon as I get my newer boards, I'm going to make a new video on all the PTTCO transceivers that I, both versions, actually I have them over here. And we're going to talk both about the standard PTTCO, the regular one, and no, wait, this is the sorry, this is the minimalist CW transmitter, and the PTTCO evolved from this one. So this is the standard PTTCO. I have the PTTCO 2 version over here close by, but right now it's connected to a bunch of things because I've been playing around with it. So this is the PTTCO 2. This one, it's also in, it was in a bunch of testing. And yeah, I also tested the transceiver without these two trimmer capacitors. Honestly, it's pretty okay even without this, and for some reason you also have a frequency offset, but I will talk about more about this soon in another video, when I'm going to build to talk about these two and another simple transceiver, and I'll talk about all three of them at once, because the information fits for all three of them. But anyway, I built it without these two, and instead of C5, when it comes to the PTTCO 2, I believe in the new design is CT3 or CT4, I'm not sure. Anyway, so it's not the one that gets connected to ground, it's the other one, between the crystal and the L1. And in here I just placed a jumper wire, and right now, without any adjustments, I think it's transmitting somewhere around 29.5 megahertz, and I have a frequency offset of about 1200 hertz. So that's like 1.2 kilohertz, which is a little bit too much. Ideally would be somewhere around 800 hertz, but anyway, this is without the capacitors. I wanted to test that as well. So anyway, that's the reason about the changes on this one, and it's valid for PTTCO 2, which the board is right here. Again, I also updated the details for the low pass filter on the output for all of them. Same in here, I also replaced the transistor with the plastic one. I have these two capacitors again. And one more thing, I would recommend you to use both the PTTCO 2, also the PTTCO, and where is it, the minimalist CW transmitter. Use them with 9 volts, not 12 volts, because this way you probably extend the life of the transistor a lot more, since it's not going to heat up that much. So this is with the simple transmitters. I have over here the bias T. This one didn't suffer too many changes, just minor ones, the pins, and I think that's it. This one actually, the mini whip antenna, the Gerber file suffered a lot of changes. So what I did, and right now I'm sorry for this, but the price of the PCB board, because the size, it's a little bit awkward right now. The price increased from $5 for 5 boards to $18 for 5 boards. But the reason for that is that I had a lot of people saying that I should add that 10 microhenry inductor between the input to the stage with the JFET and the antenna pad, to avoid interferences from strong FM broadcast stations. So what I did, I actually made a little space over here and I placed that inductor. And what else, because some of the people cannot install the antenna very high, and I realized from my own experience that if you don't put the antenna really high, one thing that might help improving the reception was to have a bigger antenna pad. So I extended the antenna pad. Right now it's 3 by 6 centimeters instead of 3 by 4, so it's just a little bit bigger, and I hope that will improve the performance a little bit. And I believe I also left a point in the top side over here, which you can use to solder a wire, and in case you want to use an external whip, like a telescopic antenna, a telescopic wick maybe, to extend the surface even more and see if you can improve the performance, well, you can do that as well. So I hope that helps. I have anything else in here? No. One thing that I do want to update, and I didn't have the chance yet, is the let me go on the computer actually really quick. So let's talk really quick about some other projects that I have. Let me go from the bottom to the top. So I believe I have the minimalist CW transmitter. This with under review. I just updated them, so it will take a while until they will be fully available. So we have the Sputnik region receiver, fully updated, version 2025. The 2 scales QRP RF watt meter. Don't order this one yet if you're planning to, just because I'm preparing a beta version. It will include 2 scales RF watt meter. It will also have a dummy load, and it will have a 40 dB attenuator output, like an RF tap that you can use for your tiny SA. And they will be all in one single project. You will just have to order the meter, basically the ammeter, and I'll give you details on that as soon as I finish designing this one. The audible RF field strength meter is updated, PTT2 updated, PTT the standard version is updated. Oh, the 10 minutes transmitter, let me open this one really quick, because I don't have the PCB board right now since I just ordered it. This one is a little special because it's multi-band basically. Depending on the crystal that you're using, you can transmit on any frequency from the 160 meter band all the way up to the 10 meters band. Now this one has an audio jack output that you can connect your key directly onto the board. So the way you will install the board, it will be that in such way that it will fit this on the front panel and on the back panel, depending on your needs. I have a 2N2019 transistor, I believe, that you will have to provide a heatsink, so because this one will get a little bit warm. And for the antenna output, you have two different options. The standard version, if you order, for example, the assembled version from PCBway, it will come with these two pins, and you will have to connect the antenna connector to these two pins. Or if you want, you can use an antenna connector directly on the PCB board, and you will also have to provide the 1000 picofarads external variable capacitor. So yeah, this is a really interesting project. I can't wait to get this one. Now, depending on the band that you're transmitting with, make sure that you will have a low pass filter on the output, because since this one is designed to be multi-band, it doesn't have a low pass filter for one particular band, so you'll have a separate one. What else we have? The mini whip antenna we spoke about, the mini whip IST again, KATND updated. Oh, we also have a PCB board for the 455 kilohertz BFO, and I ordered this one as well so I can finish it. I ordered the spy bug as well just to have fun. And we also have the VLF up converter, but with this one I want to talk something about. So you know, for most of the project, if you go down, you will see both the schematic, and you'll be able to download the bill of materials. So basically the list of all the components that you will have, you will need to build a certain project. Well, PCBway also has this bill of materials, and they are able to offer you the assembled version. So if you don't feel like soldering, again, I'm always talking about this in the promos for PCBway, you can actually order the PCB plus assembly, and you can pick the number of assembled boards that you want when you place your order. But what I wanted to talk about is the SA612 chip. It's really hard to find right now. It's not that hard actually, because you can find it all over eBay, you can find it on AliExpress, you can find it on local stores. People still have stock of these ICs, but they are no longer manufactured, and they are no longer available by big parts suppliers. So PCBway cannot offer you the PCB board in the assembled version with the chip, since it's not available from the ones that they are actually getting the components from. So if you purchase the VLF converter from PCBway, the assembled version, it will not come with the IC. You will have to provide the IC yourself. But PCBway will install a socket over here. So once you receive your PCB board with all the components soldered on the board, all you have to do, you don't have to solder anything. Basically, you just have to install the IC into the socket that is already soldered to the board. Just make sure you put it in the right position, and you should be good to go. But yeah, that's the reason why this one does not contain the IC, just because it's really hard to find from big manufacturers. Sorry, the parts component suppliers. So that's it. These are all the updates. I have a bunch of new boards coming really soon. Talking about the PTT I have this PTTCO2. So the standard PTTCO was modified from the original one. The PTTCO2 was also modified from the original one, and all of them, I mean both of them, they are having a little bit of the design by G3 XBM, and I built the W80B little transceiver for 80 meters band, and I got some ideas from that one that I ended up redesigning both of these boards, and that one is nearly the same as the PTTCO2. The only difference is probably the value of a couple of the components, and the fact that it does not have an LM386 audio amplifier on the output. It has a one transistor audio amplifier, and you will have to use it with high impedance earpieces. But we will have a PCB board for that one as well, and when I'm going to make a new video about that one, we'll talk about the little details that are valid for all three of them. So yeah, these are the three of my favorite transceivers. I don't know why, just probably because of the simplicity, even though they don't perform that great, but they're fantastic just because they're so simple. So yeah, and anyway, that's it. These are all the updates for today. I'll see you in the next video. When it comes to the Gerber files on the blog, if you go on the DX Explorer blog into the shop, you will have Gerber files, and these are actually going to be free to download. But if you want to support the channel, and if you want to support me to continue building more projects and spending more time working on this, it will have that option that pay as much as you want, or something like that. I forgot the name of it. So basically, if you want to pay me $1 for the Gerber files, just because I spent all the time to design everything, you're free to do so. If not, and if you don't have the money, feel free to download them for free. So anyway, that's it for today. I'll see you in the next video with some exciting project. Until then, thank you so much for watching, and I'll see you next week. Until then, 73 from Yankee Oscar 6 Delta X-Ray Echo.